Hello all, we're going to do a chain rule example today. We have a couple of problems we're going to take a look at, so let's get started. So I've written the chain rule over here on the side of the page. The chain rule is going to be what we use whenever we want to find the derivative of a composition of functions. Now a composition of functions means that one function is sitting within another one. In this case g is the inside function, f is the outside function. So the way we find the derivative here is we take the derivative of the outside function, we leave the inside function alone, we just put it inside, compose it with that f prime, and then times g prime of x. So it's derivative of outside, leave the inside alone, times derivative of the inside. So let's get started. We have our original function up here. H of x is going to be tangent of x squared minus 7x cubed, and we want to find the derivative of it. We see that in this case we have an outside function which is tangent of something, right? That's our outside piece. We have our inside function which is just going to be this x squared minus 7x cubed. And what we're going to do is we're regarding this outside function as our f, the inside function as our g, and we'll just go ahead and put the chain rule together. And when you get comfortable with this, this is really the easiest of the three rules between the product, the quotient, and the chain. Chain is, I think, the easiest one. So let's go ahead and get started. First thing we need to know is we need to know the derivative of the outside function. So we need to know the derivative of tangent of something. Well, the derivative of tangent of something is secant squared of something. So there's our derivative of outside. We need to take that inside function, g of x, we need to put it inside of the f prime. Well, in this case, our inside function is x squared minus 7, x cubed. So it's x squared minus 7x cubed. So we've done our outside derivative of outside, we left our inside alone, times, and now we have to do the derivative of the inside. And the derivative of the inside function is going to be the derivative of this x squared minus 7x cubed. So it's just going to be 2x minus 21x squared. And that's finished. If you really want to, you can move the 2x minus 21x squared to the front. That's fine if you feel like it, but you don't need to. Next up, I'd like to take a look at this next example. We're trying to find the derivative of cosine of r of x. Now I have no idea what r of x is, right? That doesn't matter, the chain rule still works. And so in this case, the outside function is going to be cosine of something, and the inside function is just going to be that r of x. And since we know that the derivative of cosine of r of x so the derivative of that is just going to be the derivative of the outside. We leave the inside alone, times the derivative of the inside. And there we go. So we've now taken the derivative of this, no problems. Now lately in class we've been talking about this new notation, this Leibniz notation, and we've also been removing this of x as part of the r. So in class I may have written this way: cosine of r, and I'm asking you to find the derivative of this cosine of r, with the understanding that r is a function of x. That's very important. So if we believe that r is a function of x, this is the way we take the derivative. We just take the derivative of the outside, leave the inside alone, times the derivative of the inside. And using this Leibniz notation that we started using in class, this is just dr dx. So this is another way of writing the very same derivative, just a little bit simpler, a little bit cleaner. So you will be seeing that fairly often in the future as well. Anyway, if you have any questions on any of this stuff, let me know. Otherwise, stop by my office anytime, and happy mathing.